Okay, let's just dive right into this explainer because today we're taking a cosmic road trip to an absolutely wild stellar laboratory. We're looking at Caldwell 64. Now, astronomers affectionately call this the Mexican jumping star cluster, and man, it is a seriously unique grouping of stars.
So, starting our journey right at the eyepiece of a good old amateur telescope, I've got to ask, have you ever actually seen a star jump? It sounds crazy, right? But if you're observing this cluster and your telescope gets a tiny bump, or even if you just use averted vision, when you look just slightly off to the side of your target, the fainter stars around the bright center literally look like they're jumping or wobbling around. It's this mesmerizing optical trick our eyes play on us. But honestly, the real magic of this cluster goes way, way beyond a simple visual illusion.
Let's get our bearings for a second. To find Caldwell 64, or NGC 2362 if you prefer the scientific catalog name, we need to look about 4,830 light-years away, right into the Canis Major constellation. Just to put that into perspective, the light hitting our telescope lenses right now, it started its journey nearly 5 millennia ago. It really puts the massive scale of the universe into focus, doesn't it?
And this view perfectly captures what you'd see if you peered deep into that constellation. Smack in the middle, you've got this absolute powerhouse, the central O star, Tau Canis Majoris. This thing is the heavyweight champion of the cluster, and it's insanely bright. In fact, its overwhelming, blinding glare is exactly what creates that visual wobble effect against the faint surrounding stars we just talked about. It sits there, perfectly symmetrical, surrounded by this gorgeous luminous halo of fainter, unevolved B-type stars.
Which brings us to a kind of cosmic family portrait.
When we zoom out and look at the broader stellar neighborhood, we're basically seeing completely different stages of a star's life crammed into a single field of view. On one side, we have our fierce, hot, young powerhouse, Tau Canis Majoris. Being an O-type star, it is just blasting out massive amounts of ultraviolet radiation. But then, in the very same broad observing guides for this area, we find VY Canis Majoris. Now, VY is at the total opposite end of the spectrum. It's a bloated, aging, cool red hypergiant, literally one of the largest and most luminous red hypergiants we know of. But here's the kicker. While VY Canis Majoris looks absolutely stunning and makes for this epic composition in the night sky, it's really just photobombing the picture. Since it's a cool red hypergiant, it emits barely any UV radiation compared to our hot O star, meaning it has zero connection to the glowing hydrogen gas in the area known as Sharpless 310. It appearing to sit right on the rim of that nebula? Yeah, that's just a pure optical illusion based on how it happens to line up from our vantage point here on Earth.
Okay, let's strip away the visible light and start revealing the invisible. To figure out what's hiding in the glare of that bright central powerhouse, we have to swap our optical lenses for X-ray vision. And when you compare the standard optical view with this mind-blowing X-ray image from the Chandra Space Telescope, bam! It is like looking at a completely different universe. The optical light from Tau Canis Majoris washes everything out, but the X-rays? They suddenly reveal hundreds of hidden, highly active baby low-mass stars swarming around the center. Because of Chandra's killer spatial resolution, we can peer straight into the cluster's crowded core and pinpoint nearly 400 individual X-ray sources. Incredible, right? Now, those hidden X-ray blips aren't just background noise. They are what astrophysicists call pre-main sequence stars. Basically, these are young, contracting stars that are still on their way to joining the main sequence of stellar evolution. They haven't quite settled down into their stable adult lives yet. And finding such a massive, densely packed nursery of them, that makes Caldwell 64 an absolute goldmine for scientists trying to figure out exactly how stars are born and mature.
So, let's get into the deep science and the mystery of the missing disks.
When scientists looked closer at these young stars, they hit a major roadblock regarding the cluster's missing gas and dust. To solve it, they used a color magnitude diagram, which essentially acts like a super precise family tree for the cluster. By plotting the brightness of the stars against their color, astronomers can pinpoint exactly where these stars are in their lifespans. And when they ran the numbers for Caldwell 64, the results were, frankly, stunning. See that incredibly narrow sequence plotted on the graph? That proves something really special. These stars are all basically the exact same age, calculated to be right between 4 and 5 million years old. That tells us the star formation here didn't just slowly trickle on over tens of millions of years. Nope, this entire cluster was born coevally,
meaning the whole thing formed in a single, explosive, rapid burst of star formation across the entire mass spectrum. Just boom, a whole stellar family born all at once.
And understanding that timeline brings us to a really crucial piece of the puzzle: circumstellar disks. When young stars form, they're usually swaddled in these thick, primordial disks of gas and tiny dust grains. This is a big deal because those disks are literally the building blocks for planets. They are the raw materials that create worlds like our own. Usually, at about 1 million years old, almost all stars still have these thick disks swirling around them. But here is where Caldwell 64 throws us a massive curveball. Data from the Spitzer Space Telescope showed that the primordial disk fraction in this 4 to 5 million-year-old cluster is, wait for it, just 7%. 7! That ridiculously low number means we are staring at the exact terminus, the absolute dead end of star formation for this cluster. Something like 90% of the low-mass members have already completely blown away or used up their inner circumstellar disks. On top of that, Spitzer data proved that literally 0 stars over 1.2 solar masses show the infrared signature that would mean they still have a disk. The entire cluster has completely cleared out the natal molecular gas and dust it was born from. Poof! Gone in just 5 million years. This makes it a perfect template for the universe. Because it's free of obscuring dust and so perfectly uniform in age, Caldwell 64 is pretty much the ultimate pristine laboratory for studying how star clusters evolve. And I want to leave you with this thought to chew on. Caldwell 64 proves that the raw materials needed to build planets can completely vanish across a whole cluster in just 5 million years. If planetary building blocks can disappear that fast, how does that rewrite the history of our own solar system's origins? It kind of suggests the window for planet formation is incredibly tight and that the cosmic clock starts ticking the literal second a star is born.